Welcome back to the third and final video of our ADVA ALM training series. We just finished provisioning port 1 of our ADVA ALM to start monitoring and reporting any fiber issues, so let's jump back into it. Now let's simulate a fiber cut. We're going to pull the fibers between our 50-kilometer spools and see how the system would report a fiber failure. I feel the best location to view all of the important fiber information is under the Maintenance and Port Overview tabs. From here, we can see each fiber and what their status is. We're only monitoring one port here, so there isn't an awful lot to look at. However, you can pretty much see that when the fiber is pulled, which we're doing right now, it's pretty much instantaneous. If we look under the status column, where it used to be green and told us our loss value, that was around 22.8 dB, it's now saying broken with FA running. FA stands for fault analysis. So we should see the fault analysis link appear here in a bit. So let's go ahead and click on that. Once the fault analysis results are displayed, we can see where our fingerprint was originally shot, which is the green line, versus what we're seeing now, which is the red line. Drilling in even deeper, we can see that in our second and third event, our light is completely dropping off to basically nothing, indicating that we have a fiber cut around 50 kilometers out. As we can see, the ADVA ALM has helped us to identify a fiber break. Now let's see what happens when we add some additional attenuation to the line. Let's pretend for a bit and say that we've rolled out our fiber crew and they tell us that they've fixed the break and that everything's all good. So let's quickly validate their claims with our ALM. We can see that instead of it saying broken, we're now seeing a higher loss reading than expected, around 27 dB. So there's more than an acceptable amount of loss when the fiber crew is done attempting their repair. We can also run a fault analysis on this link right now to prove out our claims. So if we go into the fault analysis tab and click Start Fault Analysis, it will essentially reshoot this link. This can take up to a couple minutes to run, so we will just speed up this bit here. We can now see that instead of a total break at 50 kilometers, we're seeing it at about 5 dB off where our fingerprint was, indicating that the initial repair that was attempted by the fiber crew team wasn't done properly, and they're going to have to go ahead and fix that. So now to simulate that, we're going to take out that 5 dB attenuator that we put in there and then hook them directly back into each other. And we can see that the link goes back to the expected loss level and then everything goes green. So in summary, you should have a solid understanding of what the ADVA ALM is and its overall benefits. You should also understand that the ADVA ALM comes in two variants, the 16 port and the 64 port versions. And when pairing them with a WDM system, a coupler is needed. Additionally, the demarcation reflector is a highly recommended passive piece of equipment that would go at the far end opposite of the ALM. Furthermore, we understand the different monitoring scenarios in which we can use the ALM, these being the dark fiber and WDM system scenarios. We also covered the configuration and provisioning of the ADVA ALM, which should have provided a deeper understanding of fingerprints and thresholds and the alarming and monitoring that's possible with the system. Finally, you should understand how the ADVA ALM responds in the event of a fiber fault scenario and how to troubleshoot those results. I would like to thank you for joining me today in reviewing the ADVA ALM product. I hope you found it beneficial, and please check out wwt.com for more information on training and resources.